Okay, here's a homework problem from homework number 14. It says the lengths of pregnancies are normally distributed with a mean of 267 days and a standard deviation of 15. So before I even read the questions, I'm going to go ahead and get that marked on my normal distribution curve, which I drew here as sort of a template. It's the way you should start every problem. In this case, X is representing the number of days of pregnancy. Remember, X changes with every problem. Z-score is always on the curve. Days of pregnancy. Okay. And we are told that we have a mean length of 267 days. 67 days. And with a standard deviation of 15 days, as any woman knows who has had a baby. Every pregnancy lasts a little different, and some babies are born early and some are born well past their due date, neither of which is particularly fun. But I'm going to go ahead and mark this down here. Our mean is a very special X. It is right here at the center, and it's our 267. Okay. All right. Now, let's go ahead and answer part A. All right, letter A. It says find the probability. Find the probability, and as you remember, probability is the area under the curve, so that's what we're going to have to find. Find the probability of a pregnancy lasting 308 days or longer. All right, so I'm going to look at my normal distribution curve, and I'm going to see that the mean is at 267, so 308 is above that. It's on the positive side. I don't know exactly where it is, but I'm going to estimate it's around here. All right, always put this in a dotted line, what it is you're trying to find. And in this case, I am given X of 308 days. Okay, and I'm asked to find the probability that it's that or longer. So that's going to be these people here, those really long, those poor women who are over 40 weeks, going crazy. All right, this is the area that we have to find. This is our question mark. All right, so what we're trying to find, I'll write it out down here, the probability that X is greater than or equal to 308 is going to be equal to, so the first thing we need to do is change it from X to a Z-score. That's always where we have to start. We can't figure it out without changing it into a Z-score. That's the only way we can use our table. So we need to find the corresponding Z-score that goes with 308 days. We can see that it's clearly positive. It's above the mean. But I'm going to go over here, and I have a formula for finding the Z-score, which tells me Z equals X minus the mean over the standard deviation. So in this case, we will have the X is 308 days minus our mean of 267 divided by our standard deviation of 15. And then going to our calculator, 308 minus 267 gives 41 divided by 15, which is equal to 2.73. Remember, we're always going to round to the hundredths place because that's what our Z-table is for. Okay, so we have a corresponding Z-score right here of Z equals 2.73. It's good to get in the habit of labeling your graph. If you label it every single time, it'll become second nature. Okay, now we need to go to our Z-table and look this up. Actually, before we do that, I just realized we are above, we are greater than. We have to find the probability that Z is greater than 2.73, okay? But if you remember, our Z-table only gives us values to the left of a Z-score. All right, so we're going to have to change this to Z is greater, the area greater than is going to equal 1 minus, because 1 is the area under the whole curve, minus this part that is less than. Probability that Z is less than or equal to 2.73. Okay, so it's going to be 1 minus, and now this whole thing, I am actually going to need to go to my z-table to look that up. So here is my positive z-score table. Okay, sorry, still learning this. Positive z-score table right here, because we were to the right. We had a positive z-score of 2.73. So over here I see 2.7 right here, and out 2.70 out to the hundredths place is here. So we're just going to follow this over right to here, and it looks like it's a 0.9968. 0.9968. All right. Coming back here now to our problem, I'm just going to write this down. Sensitive, 0.9968. All right, and then doing that on your calculator, 1 minus 0.9968 is just 0.0032. Okay, so roughly 0.32%. So fortunately, it's a very small percentage of women that have pregnancies more than 308 days. Don't forget what it is we're finding. We found this area under the curve right here, 0.0032, because what the z-table gave us was this area over here, this whole area, all of this to the left, all the way out. That was the 0.9968. Okay, so go ahead and give one a try. Okay, let's now give part B a try. So here's part B. Part B says, if the length of a pregnancy is in the lowest 3%, the baby is premature. Find the length that separates premature babies from those who are not premature. All right, lowest 3%. So now whenever you see a percentage like that, you know you're actually given the area under the curve. And in fact, we're talking about the lowest 3%. So we're way out over here, such that this area right here are 3%. And fortunately, that's a pretty low number because having a premature baby is not a very good thing. So the question is, how many days of pregnancy? What is that line? Where do babies go from being premature to not premature? And so this is really the question that we need to answer. What is this value of x here? Okay, because we are given the percentage, we're going to have to use the z-table in the reverse. All right. So we don't know z or x, but we do know that this area under the curve is 39%. So the first thing I'm going to do is write this as a decimal. 39% can be written as 0.39. Apologize. 3%. Can't even read my own writings. 3% is 0.03. 0.03. And because we want to go actually out to the 10,000th place, I'm just going to add 2 more zeros there because we know our z-score carries things out to 4 decimal places. So this is what we actually need to look up. All right, so 0.0300. Let's go to our z-table. And because this is to the left of the mean, we are below, we are negative, we're going to have to look at our negative z-table. So here we go. Couldn't get the whole table on, but so what we're looking for now is we're looking in the body of the z-table. We know the area under the curve. We don't know the z-score. So what I'm going to look for as close to 0.0300 as I can find. Now there's no exact value, but I can see right here is 0.0301. That's as close as I'm going to get. And it looks like that is a z-score of minus 1.88. Minus 1.88. Yellow's not such a great color. Okay, let's go back to our problem. And we'll write that up here. We'll label our graph. Always label your graph. Visuals are very powerful. Negative 1.88 is our z-score. Okay, we're getting there. Now we know the z-score. We can now find the x value using our formula. This time, because we know z but we don't know x, we're going to use the other formula, which says x equals z times the standard deviation plus the mean. We're just going to plug that in. We have a z-score of negative 1.88 times the standard deviation of 15 plus the mean, which is 267 days. Okay. And it makes sense that we're going to get a negative number because we're going to want to be below the mean. We know we're less than 267. In fact, if you plug this into your calculator, you're going to get 239 days. Okay, so there we go. That is the cutoff. If you have a pregnancy that lasts less than 239 days, your baby's premature. More than 239 days, your baby is not premature. That's your cutoff line, 239 days. So go ahead and give that problem a try.